All right, geometry students, so here we are with our second part of this lesson about translations. We are translating with vectors. We should be able to use vectors to translate or slide figures on the coordinate plane. In this part of the lesson, we're going to be defining vectors, what they are. We'll talk about their component form, translating with vectors, and identifying and writing rules for translations. Once again, make sure you are following along with your guided notes, and let's begin. So when we think about vectors, you probably think about this Despicable Me character, but they're actually a little bit different. So a vector is a quantity with both direction and magnitude. And when I say magnitude, I mainly mean size. So in the vector shown in the graph, a vector is represented in the coordinate plane by an arrow drawn from an initial point, in this case P, to a terminal point Q. The vector is denoted as PQ and read as vector PQ. Kind of like ray notation, but rays and vectors are not the same thing. Rays have a definite size and direction. The component form of a vector, how we write the direction and size of a vector, is written as vector PQ is equal to A comma B. Notice how we're not using parentheses here. This isn't a coordinate, this is direction. A is the horizontal component and B is the vertical component. In other words, A is how far you're shifting the vector left to right, and B is how far you're shifting it up or down. In the vector PQ on the left, not the right, if I look at the direction from P to Q, I notice I am moving 1, 2, 3, 4 to the right. That's a positive 4 shift. And 1, 2, 3, 4, 5, 6, 7 up. That's a positive 7 shift. So in this vector, vector PQ, our component form would be 4, 7. So let's try and come up with the component forms of these vectors. So here we have points A and B, and it looks like the arrow in problem 6 is pointing towards A. It's going from B to A. So I know right away this is vector BA with the arrow over the top. And if I write my component form, I need to count how many I'm moving horizontally first. So I'm moving 1, 2, 3, 4, 5 from points B to A. So we're moving 5 to the left. That is a negative 5 change. And now I'm moving up 1. If I'm moving up, that is a positive change in y. So our vector would be negative 5, 1 as the component form. For number 9, I'm seeing that I have points M and N, and my arrow is pointing from M to N. So here's what my vector would look like. Vector MN with the arrow over the N. And when I write my component form, first I need to determine what's my horizontal shift. How far am I moving left or right? I notice I'm not moving left or right at all. My change in X would be 0. My change in Y, my vertical shift, would be from M to N, 1, 2, 3, 4, 5, 6. And if I'm moving up 6, that is a positive 6 change. My vector component form would be 0, 6. For additional practice with those problems, try out 5, 7, 8, and 10. Now let's try translating with vectors. So let's say for number 11, I know that triangle STU with the following vertices, I need to shift it along the vector -1, -5. This to me says left 1, down 5. So let's plot my vertices of triangle STU. So S is at -4, +2. T is at 5, -1. 1, 2, 3, 4, 5, and down 1. And coordinate U is at -2, -2. Okay, triangle STU. And I'm told I need to shift it. Left 1 and down 5. So there's two ways we can do this. We could start with our pre-image points and then shift on the graph, and that's left 1, down 5, left 1, down 1, 2, 3, 4, 5. That would be my coordinate for S prime. And then I could go back and decide what my coordinate is. So S prime would be -5, -3. Or I could just use the component form and say that I am shifting or taking away 1 from my x value and 5 from my y value. So for coordinate t, 5 minus 1 is 4. And for the y value, -1 minus 5 is -6. So coordinate t is at, or t prime, is at +4, -6. 1, 2, 3, 4, 5, 6. Here's t prime. And u prime, I'm just going to go ahead and subtract. -2 minus 1 is -3, and -2 minus 5 is -7. So point U is at -3, -7. Here's U prime. And here is my image triangle. So again, you'll notice it's the same size and shape. It's just translated down and to the left. I want you to go ahead and try out problems 12, 13, and 14 for practice with using component form to translate vectors. And you do want to notice that the vectors drawn from the pre-image to the image are always parallel. If I were to draw a line or a vector from S to S prime, U to U prime, and T to T prime, all of these lines have the same slope. They are parallel lines. Pretty cool. One last concept, we're going to identify and write rules for vectors when we're given translations on our screen. So we are going to describe a translation that maps each pre-image to its image in a coordinate notation and B as a vector in component form. So for 15, when I look at the distance from D to D prime, I'm going to count. My horizontal distance is 1, 2, 3, 4, 5, 6, 7 to the right, and 1, 2, 3, 4 up. 7, 4. And just to confirm, if I look at F to F prime, let me see, 1, 2, 3, 4, 5, 6, 7, and up 4. And if you did the same thing with E, I can see that these triangles are the same size and shape. I know that we are shifting 7 to the right and 4 up. So let's practice with coordinate notation first, actually. For coordinate notation, recall that our pre-image point is xy, and it is mapped onto the following change. X plus 7, or right 7, y plus 4. So that's coordinate notation. Component form is just a little bit different. We use different brackets for this. Here are the component form brackets. And we know we are moving right 7 and up 4. So the component form would be 7, 4. For number 16, if we're mapping the change from P to P prime, we are moving left. We're moving left 1, 2, 3, 4, 1, 2, 3, 4 to the left. That's a -4 change. And we're moving up 2. That's a +2 change. If we were to do the same thing with each of the coordinates, I'm seeing 1, 2, 3, 4 to the left, 2 up, which means for A, for coordinate notation, we're taking the point xy, we're subtracting 4 from x, and we're adding 2 to y. For vector, for component form, for vector notation, we're taking the same information. We're subtracting 4 from x, or we're shifting 4 to the left, and we are adding 2 to y, or we are shifting 2 up. For additional practice with writing rules for translations, I can provide additional practice at the end of your notes. So thank you again so much for watching. Make sure you're trying out additional practice problems. Check your answers with mine and ask for support in Math Help Desk if you need it. Thank you again for watching. Have a great day.